Hi, okay, so let's continue with this next question with competitive inhibitor. So with competitive inhibitor, we can say that this inhibitor binds to active site because it competes with the substrate, yeah? So inhibitor occupies active site for temporary. Yeah, so because it is temporary, if you add more substrate, normally problem of competition involving this inhibitor can be resolved, right? But in this case, as inhibitor occupies active site for temporary, therefore fewer active sites are available for substrate. So what you need to do to overcome this problem, so you can add or adding more substrates reduces chances of inhibitor binding. Okay, all right. Now we have a look at following question on enzyme affinity towards substrates. So in this question, you need to use the data provided by this table to draw what we called a double reciprocal or line-Weaver plot. By drawing a line-Weaver plot, we can determine how accurate or the accuracy, the affinity of an enzyme towards substrate. So we can know the accurate substrate concentration and accurate rate of reaction. So based on the value given below, so this is substrate concentration, this is rate of reaction. So the first thing you need to do is to make table which consists the value of 1 over S, okay, and value of 1 over V. So how you want to do it? Simple. You can divide 1 over 2 for the first one to get the value of 0.5. 0.33, so I write down the value first. Try it at home. so now the value of 1 over V, so you can calculate it as 1 over V is like 1 over 2.9 equivalent to 0.34. Okay, so I write down the value first. Okay, so from this value of 1 over S and 1 over V, now you can construct a graph aligned with a Berg plot. Let me show you the results that I get. Okay, so I'll show you here. So you can plot, you make line, okay, x over y over x-axis here, whereby the y-axis is for 1 over v, the x-axis is 1 over s, and then you put in the value that you get when you reciprocal the value from s to 1 over s and v to 1 over v. So make a straight line as shown here, and have a look here, lines that intercept the y-axis and the x-axis. So when they intercept these lines, now you can determine the Km and the Vmax. So the first thing first, once you already label, identify 1 over Km and 1 over Vmax, then you can determine the value of Km and Vmax. So my value for 1 over Km is 0.2 because it intercepts the x-axis 1 over s. So the value is 0.2, okay, minus 0.2. And then for the Vmax, it intercepts at 0.1. So you can determine the value just by changing this 0.2. Okay, do the calculation, take out the minus negative, you will get the answer as 5 micromolar. And for the Vmax, you do the same thing, you will get the answer as 10 micromolar. Okay? Alright, so I proceed to the last question. So this question involving two of enzyme reaction. One is enzyme reaction in solution. The other one is immobilized enzyme. We can clearly see with the technology involving immobilized enzyme, more amount of products produced than enzyme in solution. Okay, so based on the question given, an investigation was carried out to compare the activity of a particular enzyme in solution to its immobilized form over a range of temperatures. So the results have been shown in this figure 3. So what you need to do by looking at these two curves form, you have to compare the effect of temperature on the activity of enzyme in solution and immobilized enzyme. So there are many things that you can talk about or you can interpret from this graph. We can say that both of the enzymatic reaction, enzyme in solution and immobilized enzyme, show that enzyme activity both increases as temperature increase, but up until to what extent? Because we know that enzymatic reaction increase as the temperature increase, but after that we can see that two of these enzymatic reaction, the curve shows the other way around of the enzymatic results, okay, because we can see that the amount of product is different, and we can say that for the immobilized enzyme at higher temperature produce more product compared to enzyme in solution, whereby at enzyme solution pula optimum temperature is about 30, and then the amount of product is at that much, but it's like lesser than the amount of product produced by these immobilized enzyme. So after you identify, you interpret, now you need to write in proper way. Okay. Okay, so we can say compare, right? You need to compare. So I can say that both activities increases as temperature increases. So up until to what extent of temperature? So based on the graph, I can say up to 20 degree Celsius, roughly about 20 degree Celsius, because it start to the curve starts to move to their own pathway. Okay, and then you can say, you can comment about optimum temperature. Okay, so let me write down first. Right, so the third one, so what conclusion you can say? You can say higher product pula, you can compare pula, higher